Okay, let's talk about sorting in Python. So if we have a list like of a bunch of random integers like this, right? There may come a time when we want these integers to be put in some specific order. And Python gives us two ways of doing this. One of them predates the other, and that is the sort method. And so again, a method is basically a function that is bound to a specific object. So this sort method will sort the data on L. And then also, more recently, Python introduced this globally available function called sorted, like this, right? And we pass in the thing we need sorted to it. So it doesn't get run on L itself. It just takes L in, makes a copy of a bunch of the items and puts it in sorted order and gives you back a list that's sorted. So those are our options, and in this video I'd like to explore basically the difference between sorted and sort, as well as talk a little bit about the options you can pass into them and ways of thinking about how to sort data. So why don't we get started with just this list that I've created. We'll just call L sort, right? So as with most methods that mutate or change the data on a specific object, it doesn't return anything. There's no output in our terminal either, and that's to indicate that it's actually changing the object itself. So if we look at this, we see, okay, there are the integers we had originally, but they're in ascending order and they're sorted. So let's just take a look at the sort method in terms of help. So looks like we have this comparator function, which I'm going to ignore for now because I think this gets phased out in Python 3. There's a key function that you can give it, which essentially lets you customize how you sort. And then there is this reverse equals false, or you can pass in true if you want, and that determines whether the sort occurs in ascending or descending order. So this set of options as an interface is actually the same for the sorted method. So if I run help on sorted, we see comparator, key, and reverse equals false. So those are similar between the two. But if we look at sort again, we can see that it has some extra notes to us and says stable sort, and it is in place. So I'm going to start with in place right now. We'll talk about stable sort later. But in place doesn't apply to the global sorted function. And it really just has to do with whether the function changes the data of the object itself or if it produces a copy of the data, right? So L sort reverse equals true. So all of that is done in place in the sense that these slots, maybe there's some exchanging of, there's some small amount of space maybe created to exchange the positions, but we're not going through the whole list and then copying it into another list and giving that back. We're giving back this original list. So if we call, let's say we call ID on L now, and now we'll sort it again. And notice I'm passing it, let's just be explicit here, reverse equals false. So that means we want it to be sorted in ascending order. So the first thing we should see is 0, right? And then we have our list. But if we do ID of L now, we should see the same number, right? And we do. And this ID is, in some sense, a location in the runtime environment of Python. So you can think of it as something like a memory address, right? So if the memory address is the same, then that means that the thing that we have after sorting it is the same. But not so with sorted. So we'll see. ID of L, sorted L. It prints out the values indicating that it's producing a copy. So we do ID sorted L. We have a completely different address, right? So that's just a long-winded way of saying that the global function produces a copy and thus has to copy over all of the original items in the list, and that the method version mutates the object itself. Now, you might wonder, like, what's the point of using sorted, the global one, over using list.sort? And I think the main advantage of using sorted is that you have access to the list before it was sorted, as well as the list after it was sorted. So, like if I have L and I do sorted L, let's say just reverse equals true, right? So I still have access to L, sorted L, and L. And that may be beneficial to you. It depends on the problem that you're working on. But that's one advantage of using sorted. But one advantage of using the sort method, which if you do, let's see, if we sort L with reverse equals true, so we should get the list in opposite order. Now L, we can't get back this original order, so it's lost to you, and that's what's meant by in place, is that, you know, it's mutating the thing itself, and so that has some advantages in the sense that if you have a really long list, imagine a list with just a really large amount of items, that is going to save a lot of memory because there aren't all this copying process that sorted involves. Could be, you know, it's going to grow with the length of the list. So if you have a list of 1 million items and you call sorted on it, that's not going to perform as efficiently as if you did that list with the sort method, right? Another thing that I think is beneficial, basically it's sorted. The global function gives you access to the list before and after sorting, but it requires all of those elements to be copied into a new list, so it's less memory efficient and it could take longer. And sort does everything in place, so it takes less time and it's, I guess, more efficient. The only downside to calling L.sort is that, I mean, in generally, like in large code bases or maybe like a complicated problem, mutating objects themselves can sometimes just be confusing, especially, I mean, there's cases where if you're using threads or something, you know, mutating a method versus using a copy, mutating it is going to be less, it's going to be less clear what the list is at any given point in time. So just keep that in the back of your mind. Of course, just learning to program is its own adventure, and I can tell you this, but I think ultimately you need to be bitten by this problem in order to really understand the benefits of each approach. So, okay, so we talked about reverse equals false. We talked about the differences of an application of sorted and .sort. Why don't we talk about this key function? I think that this key function is actually pretty cool. So I'm going to make a different list now. I'm going to say, I'm going to go back to my list of cities. So Boston, Seattle, New Haven, Mexico City, Portland. Okay, we have a list of cities, and there's 5 cities in there. So let's just use the dot sort method for now. So if we want to, sorting basically proceeds by comparing, especially because this is a list of strings. It compares these items in lexicographic order, which is really just a way of saying like there's somebody determined like that there's a specific order that things have to be in order for us to do operations consistently, independently on data when we're sorting them. So there's some sort of canonical rule that, capital B, because capital B and B, let me just demonstrate this, right? So the fact that basically capital B does come before B when you sort it is somewhat arbitrary. So that when I say lexicographic order, it's just some sort of canonical, somewhat arbitrary rule that says that capital B comes before B. That's one example in which it applies. But say we wanted to sort in a different way. We wanted to sort based on the number of letters in the city name, right? So I don't see a way to do that particularly easily with just the sorted method, but that's actually where the key argument comes in. So if you pass in, let's say cities.sort, and then we'll say key. So what goes in here is a function that takes in each item and returns something that indicates how that item should be sorted. So, for example, like one very obvious built-in function we can use, we don't even need to write our own, although you can write your own. But one built-in function we can use to accomplish the length, sorting by length, is just the len function, right? So remember, like len is just a function, takes in an object, and it gives you an integer back. So it doesn't work on everything, but anything that has anything that's iterable should have a length, or not anything, but a lot of iterables do. So let's just say cities.sort, and then we'll say key equals len, right? So what we should see is the cities in sorted order from shortest to longest. Let's see if that works. Let's see, 2, 4, 6, 2, 4, 6, 7. Yeah, it looks like it worked. So to visualize this, think of it as going through each item, Boston, Seattle, Portland, New Haven, Mexico City, and passing that value into len, and then getting that value out of len, which is, like for Boston, it would be 6, because there's 6 characters in Boston. And then 6 now becomes a thing that determines the sort order. So, like, if we're sorting in ascending order, then it essentially becomes like, let's look at the, so like it's already sorted now, but when we pass each one into the len function, then the list in some ways does this, like it sorts and says, okay, it's 6, 7, 8, 8, 11, right? So these are the lengths of all of these strings, and because we're sorting with the key of len, that's what we get back as a thing that determines now now it maps anything, it maps the thing of length 6 to the smallest position because nothing else is smaller than it. And then it maps 7 to be larger than 6 and less than 8. So that's generally how you would sort by length. We could sort, this is maybe not the most practical example, but maybe we wanted all of the things, we wanted everything with a space in it to go at the end, right? So we want the things with no spaces in them to be considered less than or lexicographically prior to the things with spaces. So we could say cities sort, and then we can give the key equals, and then we're going to need to write some function. So why don't we write that now? We'll say def has space, and then s for string, and then we'll return s count. So count takes basically something that you want to check how many times it occurs in the object it's being called on. So s.count would count the number of space here. It would count the number of spaces in s. And so if the count is evaluated to 0, then it should come earlier, and if the count is greater than 0, it should come later in the list. So let's see, cities sort key equals has space. All right, so my guess is, actually, you know what, why don't I, because this isn't going to really demonstrate, because essentially the things with the spaces are at the end anyway, so I'm going to just redo cities here, and I'm going to say like Mexico City, New Haven, Portland, Seattle, Boston. So I sort of manually reversed it here, but so if we look at cities now, right, the first 2 items have spaces in them. So let's sort this with the key of has space, right? And because we're sorting it in ascending order, the things with the least spaces will come first. So here we go: Portland, Seattle, Boston, Mexico City, New Haven, right? So that's because what essentially each string is mapped to an integer, and then those are sorted, and then the string is inserted back into the place where that integer ended up in sorted order. So what you have here is like the number of spaces. Yeah, that looks right to me. Okay, so that's how you would sort by having a space. But what if we have, so there may be cases where we have 2 items that can't really be like properly differentiated by the sort. So like the sort doesn't really, you know, in the case of having like their lengths, you have not the lengths, but the number of spaces. You have 0, 0, 0, 1, 1, right? So there are cases where like the number of spaces, there are 2 items with 1 space and 3 items with 0 spaces. But like, what if we needed those items to be sorted in a particular order? What determines the order of Mexico City and New Haven, right? So why are those in that particular order if the only criteria we've given them is that we're sorting on number of spaces? So this brings up 2 issues. One, brings up the notion of a stable sort. So if you remember earlier when I got help, if I looked at cities.sort we have this stable sort indication. So stable sort means that if the sort isn't able to differentiate between the two, or if there's like a tie, I guess, that instead of it being in any random order that like the underlying implementation can essentially use, it guarantees that the order from the original list is preserved. So that's important because without that you might get quite unexpected results, and there are certain situations in which having a stable sort is extremely important. But so that's issue one, stability, sort of predictability when the sort function doesn't have any visible effect on some subsection of its items. The other thing is that we can actually specify in our sort key function, the thing like we passed has space, well, we can also pass in another return value, or we can return another value on which to sort. So like if has space doesn't distinguish between two items, then we can return another value based on those objects that might distinguish. So let's say, why don't we use length and has space in one? So we will sort first by whether it has a space or not, and then based on the length. So we can write a new function that's something like my sort key, right? And it takes in the string, right? So it takes in Boston, New Mexico, whatever. And we do return has space s. And in the case of New Mexico and New Haven, or in the case of Mexico City and New Haven, this doesn't distinguish between them because they both have a value of 1 space. So it will actually go to the next item. And so what we can do is just say len of s. So in the case that we can't differentiate between the two, we go to the next one. In the case that we can, then the sorting is finished. So the idea is that this allows us to sort by one thing and then by another thing. So let's try this. Let's see what we have first so that we can properly demonstrate. So we want to first sort by has space. So I'm going to reverse this. Just to make my point clear here. So okay, so I'm going to sort this with the method that mutates cities itself, and I'm going to say key equals my sort key, and that's going to run the function that checks whether it has a space, or it returns a number of spaces, and then also it returns the length. So the idea here is to sort by number of spaces, and then if there's a tie between some various numbers of items with the same amount of spaces, then it should sort by their length. So this, there may still be a case where something has the same number of spaces and the same number of length, or the same number of characters. So in that case, that stable sort property will still apply. All right, so let's see if this is right. So all the things with spaces are at the end, and the things with, yeah, I mean, so these are all 1. These all have, or these are all 0. They all have 0 spaces. And they're also sorted in order of length, and same here. So just to return to the function that we wrote, we are returning a tuple or a tuple, depending on how you call it. So in the case of Boston, it would return 0, and then 6. In the case of Seattle, it would return 0 and 7. So this is how you can sort by one piece of criteria, by one criterion, and then by another one in the case that that is a tiebreaker. And so the same is for sorted. It's really like whether, just to reiterate that whether you use sort or sorted, it's really about whether you want to change the object itself. So we have cities. Why don't we sort the other way? We'll say sorted cities key equals my sort key, and then reverse equals true. All right, so now the things with the most amount of spaces come first, and they are also sorted secondarily by their length, but it's reversed. And so we're doing the same thing with, for basically every object. So these two are sorted first, and then within them, Mexico City is longer, so it comes before New Haven. And then these things are sorted later, and Portland comes first because it is longer than Seattle. Seattle comes before Boston, etc. But notice it didn't change the original list, whereas if we did cities.sort, it does. All right, so this is identical to this. That is all I have to say about sort functions. So if you have any comments, just please leave them in the comment section below, and I will do my best to answer any questions. Thanks.